take a look at this function, the absolute value of x over x. You might remember from some time in your past that the function y equals the absolute value of x just by itself. We can actually write as a piecewise function if x is positive or 0, so greater than or equal to 0. The absolute value of any positive number is just itself, so that's x. For negative numbers, we know absolute value is always positive. So if x started out as a negative number, the absolute value turns it positive, which is its opposite. So that's just the absolute value function by itself. Let's use that to look at f of x here. We can also write this as a piecewise function. So I got the absolute value of x over x is, well, let's think about this. For values of x that are positive, and notice we can't use 0 for this function. It's not in the domain, since that would make the denominator 0, which heaven forbid, the world explodes and stuff. So 0 is not part of the domain. So positive values of x. That's, well, looking back at the absolute value function by itself, that's x over x. X divided by x, that's 1. For values of x that are negative, the numerator is positive because absolute value is always positive, but x just by itself was negative, so that's positive x divided by negative x, that's negative 1. So there's our function written in piecewise form. Let's take a look at the graph of this function. Well, let's see. For all positive values of x, f of x, the y value, is 1. Well, that's not very interesting. Not defined at 0, but everything to the right, all positive values, it's just f of x equals 1. For all negative values of x, that's not all that interesting either. Y equals negative 1. There's my graph of this function. Let's use the graph to think about limits then. The only really interesting place in this function, as far as limits go, is when x is 0. I mean, if I look at the limit as x approaches 2, well, 2 is positive, so the limit of x as x approaches 2 for this function is 1. If I look at the limit as x approaches negative 3, it's negative 1 because that's negative. So the only interesting thing happens at 0. As I approach 0 from, let's say, the left first, there's my function. Let's see, so I'm approaching 0. X is approaching 0 from the left. My y values are negative 1 all the way over. It's a horizontal line. So the limit, and limits, we don't care what is happening actually at 0. We're just looking close around 0, and in this case, close around 0, but to the left of 0. So my limit is negative 1. If I move over and look at the right, as x approaches 0 through positive values from the right of my function. So I'm marching along the function here. X values are getting closer and closer to 0. My y value is 1. It's unwavering 1. So if I want to look at an overall limit for this function as x approaches 0, well, the limit from the left was negative 1. The limit from the right is positive 1. Those don't match, which means the limit overall doesn't exist. Sometimes we see variations on this theme. We see the same function moved over, moved up or down, something like that. So, for example, we'll call it g, so we don't mix it up with an f. If I have g of x is, let's say, the absolute value of x plus 2 over x plus 2. We have the same thing going on, the same type of graph. The only difference is the interesting point isn't 0 anymore. It's what would make the denominator 0, which is -2. So the graph's going to look the same. If you think back to transformations of graphs, the graph's going to look the same. It's just moved 2 to the left. So for all values that are bigger than 2, I get a y value of 1. And for all values that are smaller than 2, I get a y value of, whoops, not there, over here, I get a y value of -1. So there's the graph. Oop, that's not what I meant to erase. It's okay, we can recover. There we go. So now the interesting place to look at here isn't 0 anymore, it's -2. If I look at the limit as x approaches -2 from either side, let's do the positive side of my function g, I get 1. From the negative side, I'm going to get -1, and overall the limit of this function as x approaches -2 doesn't exist. So it's going to different places from the left than it is from the right.